length of the line for the IB and IC. But in order for us to add the currents on phasor diagram, we need to first add IC and IA, because that's easier for us to add. By drawing the parallelogram means two imaginary lines at the point of intersection. This will be your IA plus IC line. Now it can be seen the length of the line and the angle of the line is opposite to IB. And mathematically, if you add two opposite lines on a phasor diagram with the same magnitude and same angle, it will give you the 0 point. It's like two lines at the same angle will subtract to each other if you add them. And this is what it shows. The two lines are opposite to each other. But you have to be very careful which line you have to add to get the same line. This comes with more practice. In this part, I have only asked to calculate the neutral current mathematically, not by drawing the phasor diagram, because that would be a little bit challenging. But by watching this video, I hope you will be implementing the methodology of parallelogram by adding two lines with the two imaginary lines having the angles opposite to the point of intersection. Now part 2 says draw a scaled phasor diagram. This is the part of the question. Draw a scaled phasor diagram showing, not calculating, showing phase and line voltages and line currents. Now there is a difference between calculating and showing. Showing means if I ask you draw the phasor diagram showing the voltage and the currents for RC circuit, all you have to do is to draw the lines, right? One line and another line for the current, for example. But if I ask you to calculate the line voltage from the phase voltage using the phasor diagram, this is the method we are going to use, the parallelogram method. So you have to be very careful when you read the question. When I say showing the phase and line voltages, you don't need to calculate. All you have to do is to choose a particular scale and you have the protractor, you follow the angles based on the equation. So here I have done this for you. Choose a particular scale for voltage and current. Simply draw the length of the lines for the line voltages and for the phase voltages and for the phase currents. The angles you are going to follow are from the calculation. So for IA it is minus 36.87 degree and minus 156.87 degree for the IB and so on. For the VCA you are following this angle. So whatever the calculations you do, you are following the same angles on phasor diagram, just showing the lines. Now this is the conclusion, summary of formulas and methods. You can stop this video now, but you can continue if you want to see that how I can summarize the star connection three-phase system. So in the star connection, we have either balanced or unbalanced system. The balanced system means all impedances are equal to each other, as you can see here. The unbalanced system means that one or all of the impedances are not equal to each other, like this. In the balanced system, the neutral current will always be zero. In the unbalanced system, the neutral current will never be zero. We can prove it by changing the impedance values, and it would show like this. Whether it is a balanced or unbalanced, we are going to use the same equation. To calculate the magnitude, we use line voltage is equals to square root 3 times the phase voltage, and the line current is equals to the phase current. And if you want to just calculate the magnitudes without angles, then you can still apply the Ohm's law, but it will not give you the angles. The magnitude of the currents can be represented as IA, because there is no difference between IAN and IAB. If you use these terminologies in the star connection, then it might be confused with the delta connection. So I suggest you to use IA here. Ohm's law, in the Ohm's law, we always use phase values, phase voltages, phase currents, constant. If you want to calculate the line voltages from the phase voltages, then this is the approach, as we discussed before. If the phase voltage is considered as a reference, then it would have the rotation 0 degree, minus 120 degree, and plus 120 degree. Whatever the magnitudes we can calculate or is being given in the question, doesn't matter. But to calculate the line voltages from the phase voltages, we must use the phasor subtraction of the voltages, the phase voltages. What if in the tutorial questions you find the line voltages given as a reference? Then it means that the line voltage VAB would have, for example, is considered as a reference line voltage, which is opposite what we did in example. If the line voltage VAB is considered as a reference, then VAB would have the angle 0 degree, VBC would have the angle minus 120 degree, and VCA would have the angle plus 120 degree. Now these are the same concepts that we applied in the phase voltage. So how to calculate the phase voltages? So you are not going to use this approach. We are going to use this approach. So that would be VAN is equals to VAB divided by square root 3 times angle of 30 degree. Same as a square root 3 angle of 30 degree. Same thing. So we are going to divide square root 3 with the angle of 30 degree to calculate VAN, VBN, VCN from VAB, VBC and VCA respectively. Of course, this is going to be an open book assessment in semester 2, and you have these formulas, methods. Usually we practice these methods in the classroom and we remember these in our classroom, but now you don't need to remember it. You can always refer to solve any questions in front of you. Of course, the Ohm's law would still be the same. In order for us to calculate the phase currents IA, IB, IC, we must have the phase voltages. If by mistake you use the line voltages in the Ohm's law, then it will give you the wrong answer and it is the wrong approach.